Today we're doing some whiteboards. There's some challenging questions in here that are going to make you think, and that's a good thing. Okay. Looking at this first one, let's just focus on the first part. Find the limit as x approaches plus or minus infinity. So I could have written as two separate problems. Find the limit as x approaches positive infinity and negative infinity, but I wrote it as one. Write the answer on your board and hold it up. If we're finding limits as x approaches positive or negative infinity, where are we looking? The ends. This graph over here gets closer and closer. It looks like it's just just positive 1. And the limit as x goes this way, it looks like it's just 0. So my answers are going to be negative 1. Gosh darn, I did it again. 1 and 0. That's my setup. What other question could I have asked you that would have given you the exact same answer as find the limit as x approaches positive or negative infinity? Horizontal asymptotes mean exactly the same thing as that right there. That's more than anything else. What I want you to pull from that is, oh yeah, horizontal asymptotes or limit as x approaches positive or negative infinity are the same. Try this next one here. Get an answer. Hold it up. We start off, we do the inside problem first. So we're really going to start off by doing the limit as x approaches 2 of the inside function, which is g of x. So the limit as x approaches 2 of g of x. Here's g of x. As I get closer and closer to 2, what number am I getting closer and closer to? 1. How am I approaching that 1? From below, from numbers that are less than 2, like 1.999. So it's, or I'm sorry, 0.9999. So it is 1, but I'm approaching it from below, so I'm approaching it from the left. Once I find this value, then I'm going to do the limit as x approaches 1 from below, or 1 from the left, of g of x. Here's the g of x graph. Here's 1. As I get closer and closer to 1, I'm getting closer and closer to 0, because I'm getting closer and closer to the x-axis. Makes sense on what we did on the first one. On the next one, if f of x is equal to that, find the limit as x approaches 3. Do it. If we are finding a limit as x approaches 3, I need to approach it from both the left and the right-hand side. Which equation am I plugging into if I'm finding the limit from both sides? Both of them, because this is going to tell me from the left, this is going to tell me from the right. So if I'm doing the limit as x approaches 3 from the left, I'm plugging in that top equation. So it'd be the natural log of 3 cubed. Then I'm going to see, is that equal to? If they're not equal, it's D and E. The limit as x approaches 3 from the right. 3 from the right of 3 natural log of 3. I should use x first here. I should have done this. Let me try that again. X cubed, and then this would have been x. So when I plug in, it's the natural log of 3 cubed. Is that equal to the natural log of 3 times 3? Are those two things equal to each other? Yeah, because using properties of exponents, what could I do with this 3 right here? Make it an exponent. 3 cubed is 27. Natural log of 27. And guess what? 3 cubed over here is also 27. They're equal to each other. It's C. It's using what we know, but hey, don't forget about other math you've learned before too. Let's try the next one here. See what you got. We are finding a limit as x approaches 0. So what are we going to do to find a limit as x approaches 0? Plug it in. If I plug in 0 everywhere, I get 0 over 0. If I get 0 over 0, what do I got to do next? Factor, cancel, plug back in. On top, I could factor out an x squared. It would leave me with this. On bottom, I can just factor out a single x. That leaves me with this. I factor. Then I'm going to cancel. All I can cancel is one of the x's because I have x squared on top and an x on bottom. Then I factor, I cancel, and finally I plug back in. I'm going to take the number 0 and plug it in. On top, if I plug in 0, I get 0. On bottom, if I plug in 0, I get negative 4. 0 over negative 4 is 0. Questions on 3. Let's get that one. Try that one next. See what you got. All right, we're doing better on this one. We're finding the limit. At first glance, what does it look like the limit is here at 3 for both of them? D and E. So if the limit's D and E, it could be D and E, but we got to check for sure. We're going to find the limit as x approaches 3 from both the left and the right-hand side. All right, so we look at from the left and the right-hand side. H from the left-hand side of 3, I'm getting closer and closer to 1. g from the left-hand side of 3. I'm getting closer and closer to 5. Is that equal to h from the right-hand side of 3, which is 5, and g from the right-hand side of 3, which is 1. 5 times 1 is 5. 5 equals 5, so my limit is 5. Questions there? Good word. Next one. Suppose that f is continuous and defined for all real numbers. F of negative 5 is 3. F of negative 1 is negative 2. If f of c has to equal 0 for one and only one value, which of the following could be c? Try that. When in doubt, graph it out. When in doubt, graph it out. F of negative 5 is 3. That is this point right here. And f of negative 1 is negative 2. F of c, so in other words, your y value is going to be equal to 0 only one time for this graph. It is a continuous function. So you're going to have some line that is continuous forever and ever and ever. There is only one time that it can be 0. Well, when does it have to be 0? Between these two numbers. Because if I go from positive to negative, the only way I can go from a positive value to a negative value is if I cross it. Okay, and if I cross it, that's the only time I can cross it if it's continuous. So it has to be some number that would fall between negative 5 and negative 1. The only one that makes any sense is negative 2. Questions there? Cool. Let's try the next one. This one's a little bit different. I don't love how it's worded because I don't want you to have the idea that in calculus, never in calculus is the question going to be A and B. Okay? This time it is. But if they want to do an A and B question, they would be like, hey, which of these parts is true? Part 1 and 2, part 1 and 3, and so on. On that one, you're trying to figure out which of those is false. You can select more than one. Go. Let's see it. Letter B, let's start here. The limit as x approaches 1 from the left is equal to the limit as x approaches 1 from the right. Is that a true statement? Yeah, I'm approaching the same number, so that one's true. So that's not my answer because I'm trying to pick false ones. So it's not B. Letter D. If the limit from the left and the right are the same, does the limit exist? Yeah, that's true. The limit exists because I'm approaching the same thing. The limit as x approaches infinity. What would the limit as x approaches infinity be? It's D and E because I'm going to keep going up and up and up. So that's true. The limit does not exist. Is 1 in the domain? What is f of 1? It doesn't exist. There's nothing here. So f of 1 is not in the domain because it does not exist. So A is one of my answers. Am I continuous at 1? Definitely not continuous at 1 because there's a big old open hole. So it is A and C. Those were the two I was looking for. Two more. That one right there. Decide what's happening. When is f discontinuous? Talk with your neighbor. Go. If I want to know when I'm discontinuous, when could a function be discontinuous? What would be true? A whole or a vertical asymptote. Either one works. Okay? Or in other words, if you get the denominator equal to 0, you are going to have a discontinuity. If the bottom is 0, that either means it's a whole or it's an asymptote. And either one is fine. It's not going to work. All right, so which one of these values are going to get both of them? It is 5 and negative 5. Take a second with your neighbor and describe where on this function are you going to have a removable discontinuity? And when are you going to have a non-removable discontinuity? Talk to each other. Get an answer. Show me with your fingers. Where is there going to be a removable discontinuity? There is a removable discontinuity at 5. Because what's another phrase for removable discontinuity? A whole. If we would get 0 over 0, but if we factored and canceled, that thing that's going to cancel is my whole. So 5 is a removable discontinuity. Non-removable would be at negative 5, because what's happening at negative 5? Vertical asymptote. Also a discontinuity, but it's non-removable. Okay, what about a jump? Is a jump removable or non-removable? Non-removable. The only type of removable is a whole. Last one here. One that we struggled with earlier. I'd say it took a long time before someone got the right answer here. Where does this function have a removable discontinuity? Talk with your neighbor, work it out, see what you can get. Let's try it. So we look at this thing, initially it's saying, all right, we need a removable discontinuity. What is a removable discontinuity again? A hole. Okay, so let's see just the functions themselves. X minus 3. What shape is that? A line. Does it have a hole? No. So that's not going to get me a hole. Negative x squared plus 3. That's a parabola. Does it have a hole? No. 6x over x minus 3. Does that thing have a hole? No, it has a vertical asymptote. It doesn't really matter, though, anyways, because it's happening at 3. And we only graph that one when it's greater than 6. So, all right, there's no holes there. So the only places that could have holes are the break lines. The break lines, which are at 2 and 6. In order for there to be a hole on the graph, what is going to happen? They're going to approach the same value. The limit's going to exist, but the value is not going to exist. Notice that both for 2, actually that thing right there, at 2 and at 6, neither of them are underlined. So the value doesn't exist at 2 or 6. So each of them could be a hole. Okay, but that's narrowed down everything else. It's not that, it's not that. It might be none of the above, but at least we eliminated 0 and 3. At 2, to find if the limit exists, to see if they're approaching the same thing, I'm just going to plug in. 2 minus 3, is that equal to, I know I should be using better notation, but I'm not going to. Negative 2 squared plus 3. 2 squared is 4, negative 4 plus 3, that gets me negative 1. This gets me negative 1. The limit from the left and the right are equal to each other, but there's not a value. Is that a hole? Yeah. B is the right answer. If we looked at D, we'd look at the left and the right. We would do negative 6 squared plus 3. That gets you negative 33. That is not equal to 6 times 6 over 6 minus 3. That gets you 11. Since those two things are not equal, what kind of discontinuity is that going to be? A jump, because it's going from negative 33 all the way up to 11. It's a big old jump in my graph, not a removable discontinuity. Questions on something we did today?